In this video, I introduce distance metric learning for face recognition. Accuracy of key nearest neighbors classification depends on the metric used to compute the distances between different examples. The distance metric is trained with the goal that the key in N belong to the same class, where examples from different classes are separated by a large margin. Euclidean distance is measured in the image space, and Mahalanobis distance is measured in the transformed space. A linear transformation L maps images from the image space to the transformed space. Large margin nearest neighbors classification is to find a linear transformation L of input space by minimizing a loss function that penalizes large distances between examples in the same class, while penalizes small distances between examples with non-matching labels. LMN seeks a linear transformation error such that the nearest neighbors computed from the Mahalanobis distance share the same class label. LMN is based on two intuitions. First, each training input xi should share the same label yi as its key nearest neighbors. Second, training input with different labels should be widely separated. For input xi with label yi and his journey neighbor xj, and imposter xl is defined as inequality, where alpha is a margin. LMN finds a linear transformation error to separate the imposter from the genuine by a margin alpha in the feature space, which is defined here. In the image space, it's hard to separate imposters from xi. However, in the transformed space, we can easily separate the imposters from xi. Loss function of LMN consists of two terms. One pushes genuine neighbors closer. Another one pushes imposters further apart. The first term analyzes large distances between each input and his genuine neighbors, which is defined here. The gradient of this term generates a pulling force to pull the genuine together in the feature space. The second term analyzes small distances between differently labeled examples, which is defined here, where this hinge loss, the indicator YIL is 1 if and only if YI is the same as YL and 0 otherwise. The total loss function is defined as a sum of two terms, where mu is a balance factor. For example, it can be set as 0.5. For more details, please check with these references. Thank you. Bye.